The idea of an Earth 2.0 generally refers to an alien world that's already Earth-like, rather than a world that could be Earth-like with a little tweaking. While planets within our solar system like Venus and Mars both offer similarities to Earth in terms of their size, position, and composition, we wouldn't be able to safely live on them without either closing ourselves off completely in high-tech, custom-built habitats, or greatly altering the planets themselves through terraforming. For a true home away from home, then, we have to look further afield than even the icy moons of Jupiter and Saturn, which are also tipped for human colonies one day. Instead, we have to broaden our horizons into different star systems entirely. There are an estimated 100 billion planets in the Milky Way galaxy, and according to some NASA forecasts, at least 40 billion of these could be Earth-sized planets, and 11 billion are Earth-sized planets orbiting a sun-like star. Considering we only have one confirmed habitable planet at the moment, our own, a potential 11 billion other worlds to explore certainly evens out the odds of us finding a second. We call all planets found outside of our solar system exoplanets, with the first exoplanets being discovered in 1992. It sounds crazy now, but up until then, we were working on assumptions that planets existed elsewhere rather than irrefutable evidence. Those first groundbreaking worlds were located in the PSR B1257+12 system and were detected by analyzing the irregularities around a nearby pulsar, which is a pulsing neutron star. Unfortunately, these particular worlds were much too radioactive to support life, but their discovery motivated scientists to search for more and more planets like them. One of the biggest operations to discover exoplanets came when NASA launched the Kepler Space Telescope in 2009, solely with the aim of searching for planets orbiting other stars. While the Kepler program suffered some problems over its course, it ultimately succeeded in its mission goals and operated for 9 years before running out of fuel in 2018. Over that time, it detected more than 2,600 planets and 500,000 stars, meaning that in less than 30 years, we've gone from 0 verified exoplanets to thousands of them. Kepler worked by detecting transits in distant stars, which is when the light they give off is blocked just a little bit by a planet traveling in front of them. More than anything else before it, Kepler allowed us to build a comprehensive map of space. As such, one of our best candidates for Earth 2.0 was found in 2015 by Kepler. Kepler 452b, which is often nicknamed Earth's cousin. It's a super-Earth predicted to be 5 times more massive than our planet, located in the habitable zone of its star system around 1,400 light-years away. Now, this isn't close enough that we can just go over there and see for ourselves what kind of planet we're dealing with, but it's not so far away that our most advanced telescopes, like the Hubble Space Telescope, wouldn't be able to get a better look at it. Unfortunately, and perhaps surprisingly however, as of early 2020, the Hubble telescope hasn't yet been used to investigate 452b, with other initiatives taking precedent. That means that right now, scientists aren't at all in agreement about what we would see if we ever were to more closely monitor it. We don't even know for sure whether it's a rocky planet like Earth or made of gas. The SETI Institute, charged with the search for extraterrestrial intelligence, has also been trying to detect radio signals from 452b for some time in the hope that it might be a source of alien life, but to no avail. The confusion has led some to cast doubt on whether 452b even exists at all, although a SETI study did estimate that there's between a 16 and 92% chance that the planet is real, which is quite a large margin of error. Even so, scientists and stargazers are well aware that in the hunt for second Earths, with billions of worlds to choose from, it wouldn't be pertinent to focus all our efforts on one distant debatable orb. And there are at least a few thousand other planets we can and are taking a look at. The closest potentially Earth-like exoplanet to us is Proxima Centauri b. It's only 4 light-years away, a much more reasonable distance, but it does also pose a few problems. Chiefly, the star that Proxima Centauri b orbits around is a red dwarf star. Red dwarf stars are the most numerous in the universe, but we're not so sure what living near to one would be like. They're much dimmer than yellow stars like our own sun, so any livable planet would theoretically need to be positioned much closer, which isn't necessarily a problem, except that a planet might need to be so close that it becomes tidally locked with its star. We don't think that this has happened with Proxima Centauri b, but we're also not currently sure whether Proxima Centauri b is even close enough to its star to be truly Earth-like in the first place. What is certain is that if any planet becomes tidally locked with the star it orbits around, then it could no longer be considered as Earth 2.0 material, because one side of it would permanently face away from its chief energy source, in some senses creating 2 worlds on one. Another often cited exoplanet in terms of the potential that it's Earth-like is K2-18b. a planet that's 120 light-years away from us and one that was also discovered by the Kepler telescope. It's much closer than 452b is, and it's predicted to have a similar temperature to Earth, both promising qualities. But while it's again orbiting a red dwarf star, it's doing so very quickly, completing a full orbit every 33 days, which is a year there for roughly a month here. While scientists believe that it certainly is possible for red dwarf stars to support habitable worlds, and that in fact a red dwarf system could even hold an advantage over our own, seeing as red dwarfs are so long-lived, to label K2-18b as Earth 2.0 would still be misleading. Imagine just how different, if not unrecognizable, our planet would be if it were subjected to a 33-day year. With all of that considered, for something that could truly be a new Earth, there's Kepler 186f. For many scientists, it might just be the best candidate yet. Once again discovered via the Kepler telescope, it's roughly 550 light-years away from us, but is comfortably inside the habitable zone of its star, another red dwarf, and it's not a super-Earth. Its radius is only thought to be around 700 miles more than our Earth's is, and it's thought likely that this planet is rocky. Upon its discovery in 2014, NASA confidently called it the first Earth-sized planet in the habitable zone, and it's still our best bet in the eyes of many. Kepler 186f is further away from its sun than we are from ours, but not drastically so. It'd mean that the days would be a lot darker and colder there, but potentially not so cold that we couldn't survive. If one day we ever devised a way to travel the 550 light-years between us and it, then we really could arrive at a home away from home, at least compared to anything else we currently know that's out there. The one thing missing would be someone or something to share it with. Because if a planet was exactly Earth 2.0, wouldn't that mean that it was already supporting life of its own? And if that's true, if it's already naturally populated, well then we've got a whole host of other issues on our hands as well. Because as much as we might want to visit or relocate to a world where we wouldn't have to spend time, money, and energy extensively terraforming it to our standards, would it be morally correct to do so? SETI could even strike gold and find incontestable signs of intelligent life before we even got there. But what if that intelligent life doesn't want to be disturbed? Imagine the situation in reverse, that there's another intelligent species on another habitable world somewhere else in the universe, and they're trying to locate another planet that's just like theirs, and that planet just so happens to be our Earth. Would we really be fine with an alien race just showing up and rechristening our home as just a second version of the one they left behind? Probably not. So finding Earth 2.0 and actually making plans to move there are two very different prospects. The second of which involves the risk of harming an ecosystem that never asked or wanted to be interfered with. It's an ethical debate that's set to run and run. On the one side, discovering other planets, Earth-like and not so, helps us to better understand the universe. On the other, rather than finding a second home for humanity, we should be focusing more on making Earth, our Earth, a better place before we abandon it. In either case, there are plenty of exoplanets out there, and it's statistically probable that at least a few of them should be able to host life, or even to precisely mimic conditions on Earth. Despite technological limitations and moral debate, the search for Earth 2.0 goes on, and the list of potential candidates gets longer and longer.